The theme lately has been experimentation and messing around with data structures and concepts and ideas with 2D and 3D diagramming. Yesterday, I unfortunately was feeling pretty tired and just wasn't thinking that straight, and things were getting hard for me to focus. I'm hoping today will be a little bit better. Overall, it's been not my best week in the world, but hey, that's the way it goes sometimes. But I'm going to continue experimenting with 2D and 3D rendering of functional representation and boundary representation of shapes, solids. And yesterday, I ended the stream attempting to make a sort of rendering method that uses quads, and didn't get it on stream, but I took a break, walked away, let my brain do its own thing, and then came back and have a bit of a working prototype. And so some of today will be showcasing that idea, moving those code snippets into a spot that makes sense, and maybe writing a bit of documentation around it, and then starting to extend what I'm learning about functional rep and boundary rep and rendering methods into some form of initial design doc and spec, maybe so that I can really start putting some firm structure and architecture around this library, because I can't simply prototype and prototype and prototype forever. I have to arrive at some kind of design, and I do feel like I'm getting closer. It might not always look that way, but behind the scenes and off stream, I'm thinking a lot, I'm still experimenting, I'm still writing out design docs and stuff like that, and it's coming along. So I'm really happy about that. I'm excited that I get to do a little bit of streaming every day, a little bit of work on the library every day. It's a good mental habit that I've been happy with, and here's another one of those days. So I have the setup, my usual setup. I've got just some to-dos here, kind of what I would hope to achieve for the stream today. Notes thing here, just in case I want to write some notes that I can turn into blog posts, and a REPL, and my org file with my experimental code in the middle here. And on the right here, I have the rendered document, and here I've got, I don't need this window, but I've got here a live server and a file watcher, just waiting for changes to this section of code here. So that's what I've got going on at the moment. And to just double check that it's working, I have, let me collapse these down again for a moment. In the sphere area, I am actually in the wrong section here. Rendering sphere definitions. So I have here quad rendering, which is what I was struggling with yesterday. And I have this idea of a quad path and a quad grid, and then you can produce a quad rendering using those functions. This, I believe, is unnecessary, which I shall find out in just a moment. So let me just make sure this updates. So I have, just as part of the I have a translate and rotate on this to shift the sphere around and angle a little bit. And I have this face here, just makes it, just colors it. So here I've got quad grid with a 0.05 step, which means the parameter u and the parameter v each step by between 0 and 1 by 0.05 every time. So if I reduce this, save that, once the rebuild occurs, this should be an even tighter grid wrapped onto that globe, which is exactly what you see. And I'm actually pretty happy with that as a starting point, which is very exciting. And using that same set of ideas, I started to work on this rectangles. So I have an axis aligned rectangle thing here, which lets me draw shapes, or lets me draw rectangles on whatever axis. So this I can do on one, so on the where the normal is pointing along the x, or pointing along the y, or pointing along the z. So if and then the magnitude of the number will change its distance from the origin. So I don't know if that's the most sensible way to do it, but it's just a starting point. It should be okay. So let me, actually, this doesn't matter there. What I want to do is make this quad grid here with the with my quad rectangle call, and I want to see if that will correctly rebuild and draw. So if I just wait a moment, it should hopefully rebuild. It's possible that I typoed something. Okay, so this is, I'm running into a problem. With how I've implemented the quad grid function. It runs into sequence and long problems when you don't have the right step size, and I haven't investigated that yet, but if I make the step size 0.2, it might work again. And it might be related to floating point errors or something. I don't know yet. I have to search, or I have to figure out the idea behind that. But there we go. I can kind of anyway draw grids. You can even, since it's just a pure rectangle, you can actually set the grid step to a size of 1, which will turn the quad, in theory, into just a single path, which it does. So you could cut it down to half. There we go. Yep. And quarter will go eighths, and then eighths. I wonder if this will work, or if this will already start to produce this error here, cannot create a sequence from javalang.long. That still works. 0.0625. Let's see if this works. The reason might be actually just related to how I've set up the step function in the quad thing. Like, it might not be correctly evenly dividing things. It might have some issues in dividing it into numbers. But the point is, I can draw rectangles. Let me do it along the X as well now. Now the reason I made the axis selectable like this is, in theory, to build a to be able to build a piecewise surface to make an entire box, which I haven't done yet, and is part of something that needs to it can become a little complex with boundary representation. So before launching right into that, I want to address this first: translate and rotate as frep and brep. And what I mean by that is, if I go into parametric here and I look at the sphere, right? One moment. So I have translate here, yeah, and rotate here, which works on a list of points. Now that works, and so similarly translate will move a list of points by the translated value. So both of these work, but they work on a list of points, which you only get from, so if I make a sphere, right, of radius 5, I don't get a list of points, I get a function. Let me do brep sphere, I think is what it's called. Right, so I get a function, I don't get a list of points. The list of points only comes when I run a for loop over it, which for a brief moment I'm going to I'm going to produce a new section here for a moment. Sampling, yeah, sampling. This is just a brief aside about so the pattern that I've been using for this, and even for the slices and the dots. Now the exact configuration of the sampling becomes different for dots and for quads, but pardon me, the basic idea is that I'm running a function through basically a for loop that does range 0 to 1 with a step size of some step that the user determines, where and you do that for u and for v if it's a two-dimensional parameter. If it's a one-dimensional parametric equation, you would only obviously have to do this for 1. So I'm just gonna see if I could wrap it up in a function that just kind of helps things a little bit. Sample, right? So I'm gonna sample some function with some step value, and what I don't know actually let's see if I can That's not what I'm looking for. Let's do, is args a function? Let's do arg meta I wonder, does this produce anything useful? No. Let me check. Oops. If I go here to, oops, Clojure spec guide fdef. Right, so there's ways to do higher order functions. Okay, so higher order functions are common in Clojure and spec, and it does provide fspec to support specking higher order functions, which is what I'm wondering about right now, right? Because what I'm kind of building up toward is the idea of for sampling, I kind of want the sample function to know if the function I pass in expects a single parameter or two parameters or however many parameters, because then you can have one sample function that automatically determines it for you. So let's just start. Well, so sample sample one. So we'll just manually make two functions, one that does one that does two, and then maybe we could make a function that wraps them in together, right? So, or something. So, but I'll start with a very basic idea here, right? So you pass in a function, you pass in a step, so all you do really is for t range 0, 1 step size, and then all you do is run the function. You map the function over t. No, you don't even need to map it. Oh, you also don't need, you could just do let t be that sequence, and you return map function t. Let's find out if that makes any sense by doing, I made a line function a little bit earlier too, right? brep line. Yes, so you can give it 2 points. So let's do 0, 0, 0 and 5, 5, 5. So it's just a line from 0 to 5 on all 3 axes. So I get, let's make it a symbol. So if I call a 0.5, for example, it should give me the result 2.5, 2.5, 2.5, which is exactly what it does, because halfway between 0 and 1 is the exact middle of the line, right? Which you can kind of do in your head for simple lines. So that works as expected. And so what I want is now if I do sample 1, right, of the function a and a step size of 0.1, it looks like, if I count that, I should see 10 samples, because it's range 0 to 1 with a step size of 0.1 is all those numbers. If I count that, I guess it gives me 11 samples. Is that the case? Yeah, oh, because 1 is inclusive, I guess. 0.1, 0.2, 0.3, 0.4, 0.5, 6, 7, 8, 9, 1. Yeah, okay, that's fine. That works okay. So anyway, the point is, I have 11 samples from that function, and it has indeed produced 11 results. Let me just double check that I didn't shadow anything. No, okay. Wait, what does satisfies do? Oh, it's protocol stuff. Okay. So, if I now make sample 2, function step, right? It's going to be the same idea. Let t well, do I need to, this time I can do it in a for, because that'll be fine. For u, range 0, 1 step, and v, range 0, 1 step, and then I want to run the function on uv like this. Oh, I should make this f, not fn, because that yeah, there we go. That would be bad, because function fn is already it's already a defined thing. Can't take value of a macro, right? Okay, so sample 2, if I make a, well, let's do a sphere 5, right? No. Oh, brep sphere. There. So if I do b, Glutex, hey, how's it going? 0.5, 0.5, whoops. Then I get a single point out of there. If I sample 2, that should work the way I expect. Step size of 0.1, there we go. How's your day going, Glutex? I think I'm pronouncing your name right there. Yeah, it looks like it. There must be a way to kind of abstract this out a little bit. Fine, just trying to find a programmer. What do you mean by that? Like you have work to do and you're trying to hire someone? Is that what you mean? All right, let me see. Right, so I'm looking through spec here to see if there's a way that I can use fspec to kind of help me get what I want, right? I want to be able to determine, given a higher order function, how many arguments it's expecting before I run the function itself. So I have no idea if there's an easy way to do that. So that's kind of what's on my mind at the moment. See if I can do it. I realize, actually, maybe I don't need to. Let's do define sample, and I do the function f and steps, right? So what I can do there is let params, or n, hey Glutex, what kind of program are you looking for, just out of curiosity? Like, I'm not totally sure what you mean by trying to find a programmer. Right, so the idea I have here is just to, instead of trying to discern by the function being passed in automatically, if I just have the user of the function provide the number of steps they need, and they can call with 1 step or 2 or 3 or whatever, then you can automatically get the right number of samples from that, I wonder. You're trying to write it, but your English doesn't let you? Is English a second, or is English not your first language? Is that what you mean? Second language? Nice. I find that very impressive that people are very capable of learning multiple languages. I live in Canada, so in theory I should know French, but I don't practice it nearly enough, so I don't consider myself knowing it. So it's always really nice to see people doing that. Always reminds me that it's on my list of things to learn and I should learn it. But anyway, that's a total tangent. So I don't know that I could actually help you out very much right now, but have you tried, or are you able to post on sites like Stack Overflow? Perhaps there's you could post a question on the forum of whatever language it is, whatever programming language it is. Or if it's job postings, then I actually have no idea where you would go for that. So if you're looking for help from me directly, I am sorry up front, I probably won't be able to help you with your situation. But if you're just tuning in and listening to me while you're solving your problem, then feel free to ignore me. I hope you can sort out what you need. And params is just the count of steps. Let's have a look and see that works. Oh, it's not something like that? Oh, I'm misunderstanding you. Sorry about that. Steps. So if I do sample, right, and I pass it some arbitrary function because it doesn't matter at the moment, and steps, if I do 0.1, 0.1, oh, and params is what I should be doing here. It's 1 because I'm supposed to do it this way. So now there's 2. So if I do this like that, that's 1. Okay, so that is reasonably good, I suspect that that's fine. So then, can I, let me see. For I wonder, let's see here. Loop. It might have to do this as a macro to achieve what I'm trying to do. Oh, well, for step in steps, right? Do another for loop. Hey Lumi, how's it going? Hey Glutex, you're starting Udemy in a week. Says that I taught myself. Maybe I have some advice. Potentially I could have some advice. It does kind of depend. I mean, in general, if you're going to be using Udemy as an online class, I'm pretty sure that those classes tend to be geared towards beginners anyway. So if you would be going in completely fresh, there's a reasonable chance that the course itself will be able to guide you onto that. But I guess that probably does depend on the course itself. But if you have anything more specific, I might be able to help you, but I might not. I don't know. How's it going, Lumi? I have no idea if this is, I don't need this, if this is smart or really silly, right? But, so for step in steps, you would just do, doing fine. My stream times fit perfectly past your workday. Well, that works out in both our favors, I guess. I mean, assuming assuming you don't mind tuning in. I don't mind you joining, I'll say that much. Hey Glutex, if you're still here and listening in, by the way, Lumi has been tuning in to my streams for a bit and chatting as well, and from what I can discern in the chat, Lumi is quite knowledgeable with programming and software engineering in terms of process. So feel free to just put questions in the chat in general, and perhaps other people can read it and answer as well. So 14 years of experience now, so yeah, that's plenty. So Lumi, yeah, don't let me speak for you, of course, right? No one has to answer any questions, but perhaps Glutex, Lumi would be even more enlightening than myself. So Glutex, you wanted to start with Python then jump to other languages. My opinion on that is that really that's pretty fine. I started with Python as well, actually. I don't even remember how to do it anymore though. Let's see if this is actually going to do it. No. Anyway, Python, one really nice thing about starting with Python is there's like so much content on the internet about it that you really can scratch together enough knowledge to make things that work. And then there's more and more content about better and better engineering practices about it too. So it isn't a bad place to start, and you can go deeper and deeper and deeper into it. As for making switches over to other languages, Lumi the other day recommended a book, SICP, Structure and Interpretation of Computer Programs, I think. And the point is not to read that book specifically, but that more like fundamental concepts about programming, I do believe, extend beyond the boundaries of single languages, which makes them more powerful but also kind of harder to learn. So that's a long tangent, all to say, I think it's a pretty reasonable approach to learn something like Python, and then as you are doing projects on it and learning and learning and learning, you'll kind of run into other languages that might be really interesting, and then you just kind of follow your nose a little bit. At least that has been kind of how I ended up where I'm at now. And that's not to say I'm an expert in anything. I've got so much to learn. But you can't really go wrong just starting, because there's always so much to pivot around to, right, as you go. So what I am attempting to do is make a sample function that will sample a parametric equation without me having to like manually do sample 1 or sample 2. I just want to, if I pass it a function that takes a single parameter, I want it to sample it. If I pass it a function that takes 2, I want it to automatically do that too. And part of me is wondering if this is the spot to do like a def macro sample, but I'm not sure. You're starting university, so you want to learn it properly in 4 years, maybe other languages. Low-level languages like C force you to think about things in the lowest level, but it's a lot of work until you see the big picture. High-level languages like Lisp and Haskell, it's hard to see how the machine works, and you can get lost in complexity around type systems. Python's good for real-world engineering and problem solving. Hey, Glutex, just, I think asking for contact info and stuff might be a bit of a no-go, but if you guys wish to do stuff like that, it's probably wise to do it through PMs and whispers. But to go back for Lumi's thing there for a minute, Python. Oh, don't let me police you guys too much. I don't want you guys to, you know, post stuff on the chat that you're not comfortable to share. That's really all I'm trying to do in that one. But Lumi's point about Python being good for general engineering is totally true. There's libraries for everything in Python. Hey Lumi, thanks for engaging and answering some of Glutex's questions. By the way, that's nice. I want to encourage that in general for anyone who might be watching and not chatting. It's totally cool to join in because I'm just here doing my own code. If people are asking and answering questions of their own, that's completely cool with me. Well, for step in steps, you can do a variable like this. No, that won't do what I need it to. I can do the thing that I know how to do right now, which I don't think is the clever way, right? If equals 1 count, then you do sample 1. F and first of steps. Otherwise, you do sample 2, F, apply sample 2. Well, there. Which just feels clunky. And steps, first step, second step, steps. So now let's try sample A, 0.1. That doesn't even work because wait a second. What? Oh, this is not a thing. There. Right, sample A, 0.1. Sample B, 0.1.1. That didn't work because sample 2, I did something wrong there. Okay, works there. Oh, this isn't destructured or anything there. Okay, well, let's just be as lazy as possible for this one right now. Second steps. And then put a little note here. Does it make sense to make a def macro? You could make a for loop with n params Yeah, I don't know. I'm just not, that's not that big a deal right now, so I'm not really thinking about it too much. There's probably a smarter way to do all of that anyway. But let's just make sure it works actually. B.1.1. Oh, sample. There. You could build up the for loop one range S expression per parameter as determined by the number of steps the user gives. That's fine. So, So that was a bit of a digression even from the first thing I wanted to change up a little bit here. I managed to get a quad rendering thing after I quit the stream. I needed to walk away from my computer for a while and just not think about things because I was so stuck yesterday. But hey, that happens sometimes. Hey Glutex, if you're still there and you feel like answering questions, are you going to university for like a computer science degree or a computer engineering degree? Of course, no obligation to answer. I just am curious because it sounds exciting. All right, this is what I want to focus in on, the translate, because that is somewhat straightforward. So what I have here is a translate function that works on a list of points. And the thing that kind of sucks about that is that if I want to, let's say, where's a good example of it? Here, with this quad stuff that I've got just kind of half effective, you have to generate a list of points from the boundary rep object, or pardon me, I should say the boundary rep function. You have to make the quad grid and all of that stuff first. You have to reify it in some sense, and then you can run the translate and rotate on that list of points. But it kind of would be nicer if you could have a translate and rotate that worked to produce a, so instead of having to reify the thing into a list of points, you can translate the whole function and it still operates as a function. So then you could just make a high level function that's a compound of a boundary rep and a bunch of translates and rotates and all kinds of stuff like that, and then only sample at the end. That seems to me like it'd be a little more useful. So that's kind of the idea that I want to experiment with here, brep translate. And I'll take, that'll be a function, you take some function and some translation, move x, move y, move z. So it's not that different. and then you do something, which I will fill in a moment, but time for a customary bathroom break. I shan't be long. I'll be like a few minutes. All right, back at it. Okay, so right, so if I'm giving it a function and it's a brep function, and I want to translate it, it'll just be that function the output of the function itself plus the translation. So it'll be function of some number of arguments. So let's assume for a moment, let's just do the sphere one for a minute, start with that. It'll be a function of that where you call, where you do map v plus the output of f uv on over, I don't know if this is this a good way to write that out? I don't know. Well, x my mz. So the this here is like technically needless destructuring because I keep it exactly the same there, but I kinda like, the reason I had that was if I make this function and you call it brep translate and you look down at the signature, you can kind of, just from that line, you can guess the shape it's supposed to be, but that seems maybe like not the correct way to convey that information, right? Like, it would make more sense to make it a doc string, I suppose. But for this moment, I'm gonna see if this logic even makes sense. So B is a sphere. So if I translate that by 10, 10, 10, that should give me a function. So if I def C as that, it should work the same, 0.5, 0.5. Yeah, so if I do B, 0.5, 0.5, it gives me effectively 0, negative 5. And so if I'm translating that sphere over by 10, 10, 10, which is what I did with C, 10, 10, 10, it makes sense that the parameters 0.5, 0.5 of B, which are 0, 0, negative 5, as is the result, translated over by 10, it makes sense that it's 10, 10, 5. That works. Now the problem with that, or the problem with this yet, is I have the concept of a line, which is, so a line from 0, 0, 0 to 1, 1, 1 takes only a single parameter. Oops. brep line. It takes only a single parameter, but still produces a point in 3D space. So you still can translate a line, but you can't correctly, the way that this is, the way I've written this translate function, it breaks that because it calls the function with a u and a v, which won't work. So I need a way to deal with that. And I don't know how to do that, not yet anyway. I'm wondering if, oh boy, no. Clojure dot REPL/doc meta. What does it do? Returns metadata of an object. Nil if there is no metadata. Okay, so there's no metadata, but is there a arity? I am thinking if I make every brep function something like this, it's a function of n params, then I could always, I don't like that though, that because you could then, now any anonymous function that's a higher level function that is from the boundary rep stuff, you could pass it any number of parameters and it won't error on that. I don't know if that's a good idea. It doesn't feel like a good idea to me. Okay. Let me see about Clojure, find how many args a function requires. Higher order functions, functions as arguments. Double op, yeah. Anonymous function is a function without a name. They can be defined with the function literal or with fn. Yes. The return function from adder is a closure. This means it can access all the variables that were in scope. Yeah. Right, that's nothing new to me right now. Okay, that's not quite what I'm looking for. Vrep sphere. Is there anything that has meta? Meta? No. Oh wait, maybe I have to do this? Nope. Okay, that's maybe a dead end. Tools, let's CLI. See if there's anything useful in here. Yeah. No, that's, I already know that. What if I do the n params here? If I do apply f params, is that going to work? Okay, so now A is a line, it takes only a single parameter. B is the sphere, it takes two parameters. So if I do brep translate, a by 111. Oh, right. Call it because it's a function. Boosh. Okay, so if I do that, if I give it 0.6, is that going to work now? Wrong number of arguments passed to the line. Oh, of course, that makes sense. If I do it this way, now it works. And now if I do the same, brep translate b by 111, if I pass it just 1, it should fail. Oops. Yeah, wrong number of arguments passed. 3. Oh, if I could format my stuff properly, that would help a little bit. brep translate b 111. There. 0.6, this should still fail. Wrong number of arguments passed. Now if I do 0.6, there we go. Okay, so that was a little more straightforward, and it's probably not a horrible idea. Let me see. Let's put a little note here though, just in case. Split. It makes sense to have a higher order function version of translate. This keeps the representation as brep for as long as possible, keeping things small and concise. The idea is you can build up complex higher order functions to fully describe a part or assembly and sample it late. Example, only call the function in a rendering method. To wrap both brep surfaces f of uv and curves, which are just f of t or f of u, leave it as t. To wrap both of those surfaces and curves, I currently am using end params to allow any number of params in the translate function. I suspect there is a more effective approach, perhaps using a def macro or some other quote unquote approach that still uses defn. I don't know, but that's a little note for myself, hopefully to revisit that a little bit later. But let's move translate above rotate because it's easier. So here I have let's see. So I can split here and write this is a higher order function approach to rotate. And I can actually use, there's some similarity here. I can use rotate point basically as is and make a new brep rotate Euler that doesn't take basically it's just a single point that's rotated about a set axis. So defin brep rotate will take, just like translate here, I have the function and then the translation. Here I'm going to have the function and the theta x, theta y, theta z, which will be, let me see here, rotate about axis. It's just going to be rotate point. Yeah, so I can just make it a function of and params, and then it'll return rotate point. Oh no, I have to do a thread first macro here actually. Thread first. The result of running f on apply f to the parameters. So that gets a point, and then you run that point through rotate point. Right? And then the thread first puts the point in this argument position, and then the axis is a z, a y, or an x, z, theta z, and the same z, y, x, z, y, x. That should work. Let's find out. So if I do, okay, so A of 1 is at 555. So if I rotate that by 90 degrees along Z, I should see it should turn into -5 in the x, and then 5 in the y, and 5 in the z, something along those lines. One of them will turn negative. So if I, so if I rotate point A1 about z by 90 degrees, yeah, -555. So what I want to check is if I do the brep rotate of the function A, and it's 0, 0, 90, like that. So that gives me a new function, which yet again I have to call it. So 1 of this should be -555, which it is. So that appears to be working the way I want it to, which is Very exciting. So, in order to see if that's working the way I want it to, actually, what I'll do is let me mess around with this here. Yeah. So I'm going to go and change up how I drew this here. Let me save this first for a moment. And I'll get to work on this dot rendering thing here. So what I have right now is dot sphere is a mapping of the dot draw function over the transform sphere points, which I have up here, transform sphere points, x sphere points. I have the list of sphere points and I rotated it and translated it already. So let me just check this here. Yeah. So I should be able to make a different def my let's just call it x sphere is going to be the translate rotate. Oh, actually, let me write this a slightly different way. I'm going to thread first the function mySphere, which is up here. So that's a sphere, a boundary representation. So a parametric surface of a sphere with a radius of 8 is mySphere. I'm going to thread that through. The first transformation I want to do is a boundary rep rotation, rotate, brep rotate, by the isometric Euler angles, and the second thing I want to do is translate that same thing by 10, 10, and 0. Okay, so this x sphere should be a function that has undergone these two transformations. Then this dot sphere, if I make a new one that's similar, dot sphere 2, I should be able to map dot directly onto a sample of 0.1, 0.1 of the function. Oh, I have to write it this way. This sample x sphere by 0.1, 0.1. So that theoretically can work. I'm going to see if it does. So so there's an error, and that is from okay, so there's an issue in the sample 2. Let me just do this. I thought I fixed that, but maybe not. Let's sample B 0.1, 0.1. It should work. Well, let me build up a little thing here. So B is a sphere in my REPL, right? Yeah. Let me build up just something in the REPL to play with for a moment. If I do xb, I want to just recreate this def xb is the thread first of B through brep rotate isometric Euler angles and the translate of 10 10 0. Okay, so if I call xb 0.5 0.5, so there's a problem there already. Okay, so something went wrong with that. If I do brep rotate B and isometric Euler angles, if I call that function with 0.5, does it work? Okay. Oh. Okay, so that part works independently. Let me try, well, let's break this down to see where it's failing. Okay, xb 0.5 0.5. Okay, so the rotate works if I do this xb 0.5 0.5. Okay, something I did. Oh, okay, okay. Of course, since I'm in this sort of prototyping stage, I am making a lot of functions with similar names, which is what is causing me quickly to confuse myself. So I was calling translate, but I need to call brep translate. So that is theoretically the only problem with this. So brep dash and frep dash prefixes on many functions is a strong hint that I can and should provide implementations separately and combine them using something like def multi or def protocols, which is basically the same thing as yesterday. Okay, so that sphere works pretty much. Let me sample it way lower, see if it actually lines up. Yeah, all right. So that's pretty cool. I'm quite happy with that, actually. So that is, I think, a superior way to do this, because it doesn't actually it doesn't calculate anything until you run the sample here, sample it. Now, I think that's pretty powerful. You can, the way this sample is done as well, you can technically sample things at different step rates along, so you can make a non-uniform grid. You can make that kind of stuff, which is really quite cool. I am very happy with that. So what does this look like if I do it the other way? This will look more like thin slices, I think. Yeah. Neat. So the next thing Yeah, so the next thing I have written here is an observation that right, so dot rendering is extremely simplistic. You map the dot draw over the sampling of a bunch of points, which is great. It works very well. It's nice and quick, and you can kind of tell the shape of the object nicely. I think that's it's just so cool. Let's do 1, 2, 5, 1, 2, 5 just for fun. Yeah. So that seems like a superior way to do dot rendering. That's no problem. But if I want to do something like slice, I'm calling it slice rendering here, where you do it, oh, that's not, let's do this. There. That doesn't look like anything. So the slice rendering is different because you have to kind of sample it differently, which sample, let me make another function here, define slice function, and steps will be exactly the same, but you do it like this for u range 0, 1 first steps. This is obviously not the final way to do this, right? Because if you imagine a situation where you're sampling something that has 3 dimensions to it, so you're sampling a solid, right? For like to get voxels or something like that. This just breaks, so it's not a smart idea. This doesn't generalize past what I've got here, so that's not perfect. But I'll leave it be for right now. So what I want to do here is make a little slice function, which is basically the same second steps. So you slice it by per layer you sample around, and then you do another layer, and then you sample that way. So slice, but you can slice in 2 directions, which you would, let me do FUV. Slice so just leave it well, that's not that's not helpful. Just leave that be. Okay, so slice calls f of u of v on a for basis. So what you end up with is a instead of just a list of points directly from that you would get from sample, just produces a flat list of points. Slice gives you a list of lists of points. So each entry in the top level list is itself a list of points. So you get flat layers that like all the way up the shape that you're rendering. So slice and sample can't be used directly together because their like the structure that comes out is different, unless I no, it has to be different. Okay, so slice is useful for that, and I'm starting to talk about that because here my quote-unquote render methods have different approaches. So dot rendering works on a flat list of points and just puts a dot at every sampled point. It's very straightforward. Slice rendering is also pretty straightforward. It draws a path per layer of the object. So you get this cool layered approach. These slices, like it's exactly the same thing that actually like hobby 3D printers do. They slice an object by stacks that are a certain number of millimeters high, and then it's just a 2D shape per layer, and then it builds up those 2D shapes to get a 3D shape out of it. This slice rendering is exactly that idea. You could also call it it's like contour maps. So like if you have a like a geographical map with elevation lines in it, it's the same idea, pretty much. And then quad rendering, you calculate the faces that come out of your UV grid, and then you remap it onto the shape, and then you draw each of those out. So this one is the most complex, and it's also distinct from this. So I do need to make them all work similarly, but different. But the underlying machinery will be different. But I have a note here: make them work like the quad. The quad grid, and by that I just mean. Let me. Okay, here, sphere. Let me make a new rendering. This is, well, let's start with, nope, dot rendering, Clojure, tangle, /param.clj. That's that. Split it again. So we've got dot rendering, TBD, slice rendering, and quad rendering. It's like facet rendering, I guess would be what to call it. I don't know. Dot rendering is, yeah, okay. Okay, so I have the spots to kind of put things into. Let me just, I'm going to run this, make sure this doesn't break, because I think this is old. I don't need that. I'm going to fill up, I'm going to get some water for a second. Right. So something broke. What did I break? What line is that? Steps param CLJ 48. Let me oh, I didn't properly do the slice. Where am I at here? Sampling. Oh, that's right here. Yeah. So this actually, I don't need this. First steps, I just need U. And here I just need V. Boosh. Save that. That should, in theory, build correctly. Indeed it does. Okay. So nothing is missing here. Let me go here and just completely get rid of this. Feels nice to just delete big bits of code, actually. It's like you explored a whole region and you know that you don't need it, which is like very useful. The only downside is if you forget and then in the future you re-implement or re-experiment and then end up doing the same thing over again. Because once you delete something, you kind of lose the history of it, unless you're committing every single thing you ever change into a change manager, git, whatever. Version control, that's the word. Okay. So here, make all render methods operate like quad grid. By that I mean they take a function f Yeah, so actually, like the ideal scenario would be you write the function something like render, and then you have a keyword that's the method by which to render. So render keyword quad, and then it takes the function you've got, and with default values for the step size and everything, it just renders it on your behalf, basically. So shall I move this into the quad rendering section and start, let me change this to render quad. And this will be render quad. My sphere with a point size of 0.25, which is what this does. But let me redefine quad sphere. Make it a little cleaner since I can do that now. So I already have the transform sphere function. So actually, def quad sphere should be really simple. It should just be render quad of not yet. I have to actually make this whole thing here map this business. Yeah, no, I was a little preemptive on that one. This has to be so this needs a bit of work yet, because this still needs to be quad grid. Let me comment that out of the way so it doesn't mess things up. And here, this is not finished yet. So let me uncomment this so that I at least have the visual still there. Oh, did I mess something up? I did indeed. I thought I deleted this. There, that should work now. Oh, render quad. Quad grid. Okay, so just make sure it's building okay, and then I can get to, there it is. Okay, so I want this, I want to have a function here that is called render quad. Now actually, rendering, if I do up here, begin source, Clojure, tangle into the param file, and I do def multi and how does that work again? Clojure def multi dispatch on keyword. I forget how to write that, but it's not that hard. Def multi, the name of it is going to be render. Shoot, this isn't actually that hard, I just don't remember. Okay, def multi, f identity, hierarchy. I don't want to do that, not yet. Okay, this is probably the simplest example. Def multi draw shape, def method draw square with the object, drawing that. Oh. What I'm thinking of is you just do render first. Is that, let me see if that even first. Let's try that. Let's see. Def method render quad quad, and then def method render default. Is that gonna work? I don't remember if I did that right. So if I do render 0 arguments, render quad, so I'm not doing it correctly, not yet anyway. Let's just put a note here. It might be worth making a multi-method for rendering brep and eventually frep compound solids. Rendering approaches so far are quad dot slice, and that was it, right? Dot slice quad. It's there. These don't work yet, so fix those later. Actually, let me do it this way. I'll just do comment so that they're not disrupting anything. It should be fine. Okay. Comment. I forget how to make this work. It's not hard. Just look it up later. Right, so this is not a bad idea either. Dispatch on the first argument. Oh, that's pretty much exactly what I want, isn't it? I'll try that quickly for a minute. Let's uncomment that stuff. Just to have a base, may as well. Render, def multi render. And I want to dispatch with a function that takes approaches. Approach. So there's the approach, and then there's the body approach. Okay, so that's the def multi render, and then def method render quad is going to be yeah, right, and then default. Okay, is that going to work this time at least? So if I do render quad and the body is something empty, 2 args pass to what? Huh. I thought that would work. Render okay. This is something I'll sort out. I don't need it right away anyway, so that's fine. If I go now and fix up the idea here, this will probably be the last thing I do today. Render quad is a function that takes a brep function, and then it's going to render out with some defaults, some default step sizes. It's going to render out into a quad just all for me. So all I have to do is kind of merge these 3 things together into a nice function. So one thing I know I don't need in this, so I do need to use closed path. So let's start there. Closed path. I have to map it actually. Map the closed path function right? The closed path function actually let's take one step back even further for a moment. Let's let grid be quad grid, which takes a function and a step size, which is going to be let's just do step here for the time being, because that'll make it a little easier to pull out later. So you got to do quad grid with the function and the step. So that gets you a grid. And that's really all you have to do, right? Because then you can just map closed path over the grid. So let's render quad. But is there a more concise way to make a quad grid? Right? Because that's kind of a sample function. So I have sample and slice as works in progress up already. So you do want to sample quad sections, right? So quad grid. Well, first of all, let's see that render quad works out the way I want it to. So if I do def quad sphere 2 as render quad of X sphere, right, I should see no change. Comment is broken because it thinks it's like a function or a symbol. See if it builds. It does not. Closed path doesn't exist in this context. Are you sure about that? Oh yes, of course, because I have not in this namespace stylo.draw as D. So I have to actually go d/closed here, quad rendering, there. That should work now. Perfect. Yes, and of course I turned off distracted for a moment there. Okay. Right, so closed path here, if I want to do grid, I need to do this. Face will color the faces again. I think. Oh, no, I have to, it has to be like this, closed path, this, face, face, like that, and that'll work. Sweet. Okay, now is there a way to make this a little more effective. Well, let me go ahead and do this. Not that. This. Cut that, bring it up into the sampling section. So sample and slice, and you want to slice it, or you want to discretize, quadrize, no, I don't know what to call it, but let's make this the same signature as this. So FUV. Oh, wait a second. This should be U step and V step. For U range 0, 1, U step, V step, there. Quad path is a U, a V, and a step, which should be U step and V step, like that. So you've got U plus U step, V plus V step, there. And here you've got U step, V step as well. Range U step, range V step, map apply F quad path onto U, V, and U step, V step. Okay, so we've got the same idea here and here. It'll be fine for now. And then to render quad, you do, the grid is a quad grid. I want to call this like grid, so there's sample, there's slice, and there's gridify, discretize, gridify is silly. There's a name for triangle, for making you want to mesh. It's a quad mesh. Quad mesh. Yeah, sure. Render quad, grid, quad, mesh. Let's call it a mesh then if we're gonna do it that way. So step is the default. Declose math, the closed path over the mesh. That's render quad, and now down here, since this does work, I can delete this one. And that should work for me, I think. We'll find out in a moment. Quad sphere 2, can't render it because it doesn't exist. Silly little typos and name changes. I do that a lot, but that's part of the experimenting phase, so I think it's fine for now. And quad grid, of course, I didn't change that. Render quad. Okay. Wrong one. Quad grid. It's quad mesh now. Yeah. Still. Yeah. 0625, 0625. Like that. There we go. Okay. Slowly getting somewhere. Okay, so now I have a function render quad. Let's close the boxes thing up here. Right, so quad sphere works by render quad x sphere. Let me get the dot thing here working in a very similar way. Let me get rid of this def here entirely because I don't need it. Dot sphere, and instead of that I go here. So render quad takes a step by default and a mesh. Yeah. And the dot is currently empty, but it's gonna be def and render dot, and it's just going to take a function, let step also be 025. That's something like this where right now I'm just doing a let to make the step there, and I'm hard coding it. I could probably do let steps. Maybe should call epsilon or precision be handled by a dynamic var, so that you could do like a binding and change the, so you could do turn it into a dynamic at some point that makes sense to do, and then I can just pull these out and then have the dynamic thing referenced in there. And then binding, you can, like with a binding call, you can change it kind of on the fly as you're rendering, which I think is a reasonably good way to do that. But here, if I let step be that, that's all I need. So then I just map draw dot onto sample2 of the function and the default step. So there's render dot, and if I go to make sure that that function works, all I will need to do is dot sphere is render, let's just call it with X sphere. So dot sphere is render dot of transformed sphere. So that should build just fine and have no visual difference. All I did was define the function. Yeah, we're good, and we're good there. Perfect. So stretching out a little bit. Feels good. Don't have much time left today, but that's okay. I'm feeling better today about what I'm working on than I did yesterday. I just kind of hit a wall. At least now I'm structuring my code in a little more clean manner, and then I can refactor it more efficiently. At least that's my theory. Okay, so the only things left now are to do a slice render. So let me just get rid of the B slices for the time being. So I clean that up a little bit and get rid of this part here. And X sphere points, I do believe, is not even needed anymore. So all I have is sphere, X sphere is the transform of that, which, by the way, I can just collapse here, do this, there. X sphere is this whole thing, and sphere slices is just the slicing up of X sphere UV, which is good for now, but let me copy that to slice rendering here. Sphere slices, and this Yeah. Yes, so I have a slice function up here in the sampling. Yeah. Save that. That might have broken this. I might have moved a function out of the right file, but that's okay. It's a work in progress. Yeah. X sphere in this context. That's because I've copied that into here, and that doesn't exist yet. So if I do this and this, and then now build out, render slice f, let step 1025 is a good default. Slices is slice the function by step, and then for those slices, which is what you get from this, so I don't need this anymore. For those slices, you do for slice in slices, right? You map, you do a closed path. Pardon me. Oh, I could actually just map d/closed path, right, over slices. Should work, because for path in sphere you make a closed path. Let's get rid of the translate rotate. You make a closed path, you draw a closed path out of the path, and you're not rotating it, nor are you translating it. You just have this thing, which then instead of doing a for, you can just map closed path over paths. So that should work. That should be equivalent. So if I render a slice, if I render slices like that, let me sphere defs, let's get rid of this, get rid of this, def slice sphere as render slice of X sphere, and see if that works. I shall find out in a moment if my brain is working. Yeah. Yeah. Sweet. That is fantastic. And now, just to make sure let's do here, let's swap this around, V with U. That should slice along a different plane now, so we should see this change around when it rebuilds. Indeed it does. It is slicing. Man, that does look weird, eh? That's cool. Well, that's not very, it doesn't illuminate anything. Okay. Actually, let's not do it that way. Let's do UV like that. So one thing I haven't addressed yet is the fact that so far these render methods render assuming a boundary representation input function, which is not guaranteed, or I should say I can guarantee it with some structure to the code, but I have the concept of a def, let's make frep sphere of size 8. So A takes a point, 0, 0, 0, wrong number of arguments. That is my bad. So A, you run it on an X, a Y, and Z, so a point value, which maybe should be, I should maybe rewrite it to be like that. Actually, let's do that for a moment. Okay, so parametric sphere, example of a sphere. Frep sphere is a function of x, y, z, but I kind of want it to be like this, right? So if I do that and then redefine A, now A should be a function of this, and that should work. And what it returns is a scalar distance that this point is away from the surface of the sphere. So A at 0, 0, 8 will be 0. So you cannot use the render logic I've used so far. You can't use the sample, the slice, or the quad methods on this function because it expects a point. It operates on point data, not on parameters. So you kind of have to reverse the function to be able to determine the surface from a functional representation. And the problem with that is, well, there's a bunch of things, but you can, since you have to, like you've got an infinite space in x, y, z to check for the surface, right? So like if you were to run a solver or something to find all points such that A of the point is 0, that's a ton of checking, and you can't realistically run that. So you need a different way to render the functional representation of the shapes. So that's something that's currently unaddressed. And I don't have an obvious thing to do yet because, well, except start working outside of SVG and go to canvas elements and start doing sphere or circle ray tracing, sphere marching, that kind of stuff, because then you can render frep structures that way. But I want a cohesive approach to rendering so that I can write the word I want a sphere 5, and that's my code, that's my shape, and I want to pass that same bit of code into any rendering environment that I create and have it render appropriately. If it needs the boundary rep, it uses it. If it needs the functional rep, it uses it. So I don't have anything built yet for the functional representation, rendering in an SVG context. So that's something I have to start thinking about, which I will do in just a moment. I'm going to check something. Okay, I'm going to be ending the stream in 10 to 15 minutes, I think. So I've got these two things kind of handled, right? So I have render methods separated out by approach, and they all do work. Right, so I have a single definition of a sphere with its translation and rotation working in a nice manner. I have the render dot of the X sphere, render slice working, and render quad working as well, which is fantastic. And now let me mess around with boxes for a minute. Just out of curiosity, I want to see my rectangle is this thing, right? If I do X rectangle is, I want to do exactly the same translate. I want to do this. Except, of course, with a brep. Well, let's do here my rectangle, X rectangle, and let me define a quad. Instead of this, let me do render quad of X rectangle and see if that works out of the box or if there's stuff I'm gonna have to change. So if this builds, that's nice. If it doesn't, Oh, it does. So we're onto something, but as you can tell, I think that's a really, really, really tight meshing, which is too... Yeah, that's way tighter a mesh than I need. So is it render dot? I always render quad slice dot. Let's change it to render dot and see if that looks any more effective. Yeah. So the default for a circle, or a sphere I should say, the default spacing, the default step size that I used, it looks good, but it might be overkill for this, right? Which is maybe a bit of a problem. The other thing, excuse me, but at least okay, that's actually good. I can clean this up a little bit. Quad rectangle and X rectangle points I don't need anymore, nor do I need this. And in fact, define X rectangle, I can just put this into here and run it through that thread first macro, and I can get rid of this. Okay, so we've got a nicer test thing to work with here. So I can render dot. Perfect. Okay. If I render slice this, is that going to error out on me, or is it going to just look like a bunch of lines? Because it is a valid brep surface, but it's not. Yeah, okay. It kind of works. Or I mean, it does work, but they're gonna be a little wonky. Okay. Okay. So the other kind of entity set, right? I can make a brep circle, but these are a brep circle will give you a point in 3D space, but is only a single parameter. So it's not a whole surface, it's just a curve. So I want my render methods to work on curves as well, but some things break the assumptions. So the only thing that should work fine is the dot. So I'm gonna go ahead and I'm gonna make this render dot X rectangle here, and I'm just gonna split out another thing and call it curves, and it's curves in the mathematical sense. First let me finish this thought. So A of 0 is 8, 0. Oh, it's only two-dimensional. Oh, I left it two-dimensional. Well, I can change that nice and easily. If I do right, x, y, 0 there. So now def A is that. Then A of 0 is a 3D point, and A of 1 is the same. Due to floating point errors, it won't be exactly the same, but it's technically the same point. And if you sample A by 0.1, you get that out of there. But if you sample 2A by 0.1.1, you'll get an error. Yes. So, okay, so that's kind of fine, but not totally, because my render functions will not work by default on curves. They'll only work on surfaces right now. So that's a bit of an issue. But let's finish building out the curve spot for a moment. Figure def x circle is thread first brep circle of radius 8, sure. Thread that through brep rotate isometric Euler angles and brep translate 10 10 0. Right, so that's translated circle, but I can't render dot of x circle without errors. I'm pretty sure that'll fail. Reindeer. And the reason it'll fail, I think, is because in rendering, right, if I render dot, pass it a function, the step is that, but here it's calling by default step. So if I make a render dot function that can handle that case, I can call sample1 f step and call it render dot curve, right? And that, so this is just screaming for multi-methods or something more clean, as to wrap it all together, which is perfect because I can do that. Or I can learn how to do that if I don't know how already. So let's see if that'll work, and if it does, I'm going to call it a day, and if it doesn't, I'm going to fix it up, and then I'll call it a day. Sweet. So let me go have a look at this. Clojure.repl/document spec fspec. Right? So what I'm starting to think about is what I just referenced here. It's parametric. Right? So we've got functional representation uses sign distance functions. That, whether or not the thing itself is 2D or 3D, it'll take in a 3D point and give you a single scalar value out, a single distance, right? So actually, let me see if there's a right. So I need some way to spec functional rep functions and a way to spec brep surfaces and brep curves, because those are both renderable in the same way but have different parameter input requirements. But functional representation is renderable in a different way but has, for 2D or 3D, the same input requirements. So I've got like I've got like a quadrant thing, right? I've got curves, surfs, and brep, frep, right? So brep curves, inputs in different anyway, this is silly, but I have different sort of orthogonal concerns with functional rep and boundary rep, but I want to tie them all together in a nice convenient way, which will happen at the render methods, and it'll happen at the implementation details. So at things like translates, rotates, so all transforms, and CSG operations, and extrudes and revolves. I'm pretty sure I can come up with methods for all of those things, but the implementation details will be quite distinct for all of those different things. But that's enough chit chat for today. I'm gonna look at fspec offline, I think. Needed for spec work on frep, brep, higher order functions. But that's important. I'm quite happy with today. I made progress on understanding what I need to do in terms of the architecture. There's a lot to do yet on the functional representation side, on abstracting things so that when I do 2D only, the idea of sketches and shapes is very straightforward, and then taking those things and abstracting the ideas in 3D sort of distinctly is still important, but things are coming along and they're getting better, which I'm really happy about. So I am going to get going. Thanks for tuning in. Thanks for listening. Thanks for participating here and there when people have participated. This month, my plan was to stream every single day to build the habit of streaming. As it turns out, I'll be going on a vacation tomorrow, so I'll be streaming tomorrow and then not streaming for a couple days. But this has been very fun and very valuable for me to do, and I like it enough to keep doing it. So after my vacation, I'm coming back in July with improvements. I'll have I'll start to add proper things into the stream, like notifications popping up on the screen. I'll have a landing website that explains what I'm doing better. I'll have a GitHub. I'll probably have a bot, and I'll have a YouTube channel where I can post non-live videos of things. So I'm gonna start putting things together, making it all more professional, and build things out from there. So I'm really excited to keep working on that. And that's enough talk for today. I had a good stream. I felt good about things, and I'll be back tomorrow, and then I'll be back in July at some point. So cool. Have a great day. Goodbye.